Okay, so in terms of looking at the byte streams, the last byte stream class that I really want to look at is the RandomAccessFile class inside of the Java I/O API. And so here, I think this might prove itself to be one of the more powerful use cases of the I/O package for byte streams. So quick overview for this presentation. We'll do a quick introduction of what the RandomAccessFile class is. We'll look at the class declaration, its constructors, its methods, and some sample code. So quick introduction here is that the RandomAccessFile in Java is a class that allows data to be read from and written to any location in the file. So that's a novelty. That's really powerful. Think about how powerful that was when we're talking about that in terms of collections, being able to read or write anywhere inside of a collection. Well, so RandomAccessFile gives us that capability to do that inside of a file. So in simple words, RandomAccessFile class allows creating files that can be used for reading and writing with random access. It means that we don't care about an ordering in how we write into it, right? Random access means access to store data is in any order that us, the user, desires. That is, we can access the data file in any order while using the file. Such a file is known as a random access file. So whenever you hear that idea of random access, and this is true with arrays as well, it means that we can index into any part of it and access or overwrite data into it. It doesn't have to be at the front. It doesn't have to be at the back. So a random access file is a file that can be used for both reading and writing. So far, we've discussed all I/O streams that can be used either for read-only or for write-only operations and not for both purposes simultaneously. So that is all of the I/O streams that we've used so far are known as read-only or write-only, right? One is a link from a source into our application. The other is a link from our application to a destination. And these streams are called sequential streams, the one we've looked at previously. So a file that is read or written using a sequential stream is called a sequential access file. The data of a sequential access file cannot be updated. So for reading and writing data simultaneously, Java provides the RandomAccessFile class. Using RandomAccessFile class, we can change the location in the file at which the next read or write operation will occur. So RandomAccessFile class was added all the way back in Java 1, and it's also present in the Java.io framework inside of the package. Okay, let's look at the class declaration. So RandomAccessFile class extends object. The class, it extends the object class and implements the data input and data output interfaces with the additional methods to support those random access functionality. So therefore, it can be used for both reading and writing simultaneously. It also implements the closable and auto-closable interfaces, super important. We always need to be able to close our streams when we're done with them. It is not inherited from input stream or output stream superclasses, right? Because those are more restrictive. RandomAccessFile has simultaneous capabilities of doing both input and output, right? It's not sequential. And so it can't inherit from those two things, which is why it extends from object and then inherits from these interfaces instead. So the general syntax to declare a RandomAccessFile class in Java would look like this. So public class, it's a concrete class, RandomAccessFile, it extends object. And so really what it's doing to get the functionality we needed to is it's going to inherit these data output and data input interfaces. And of course, closable and auto-closable. Okay, let's talk about the file pointer inside of a RandomAccessFile class. So a RandomAccessFile consists of a sequence of bytes, right? So not unlike the streams we've already looked at, it supports a special pointer known as the file pointer, A file pointer indicates your current position or location in the file. So you can almost think of the file pointer as an iterator, just like you had iterators on collections. The file pointer is a way of tracking the position in the file that you're going to read or write from. So it is positioned at one of these bytes in the file and can be moved to any arbitrary position in the file prior to reading or writing. So again, that's what we mean by random access. We have control over that file pointer. In other words, a read or write operation takes place at the location of the file pointer, and the file pointer can be moved using the seek method, which is provided by the RandomAccessFile class. When a file is first created, the file pointer is set to 0, indicating the beginning of the file. And when we read or write data to the file using a read or write method, the file pointer moves forward to the next data item, i.e. the next byte, because this is a byte stream. So let's see if I can't create kind of a visualization here. So say, for example, if we read an int value using read int method from the file, then recall that an integer is encoded with 4 bytes, right? It's a 32-bit value with the encoding. That's what gives us so many different values that an integer can make up. So the JVM would read 4 bytes using the file pointer, and now the file pointer is 4 bytes ahead. So if we do a read int, it doesn't increment by 1 byte. It's going to increment based off the number of bytes that data type is encoded. So that would be 4 bytes ahead of the previous position as shown in the figure below. So if this is where our file pointer is, and recall that this is a byte stream. So all of the data is encoded at a per byte level. That's the smallest addressable space in memory. So before we call the read int method, we would start here. And after the read int method, well, an integer consumes 4 bytes of memory, right? It uses 4 contiguous bytes of memory to encode 1 integer value. So we would advance by 4 slots in our byte stream. So then our file pointer would be here. Okay, so for a so let's suppose we have our random access file RAF. That's what we call our local variable here. For instance, if we do raf.seek and then pass in a position, we can actually move the file pointer to that specified location. So that allows us to jump around. We could do raf.seek and just pass in the value of 0, and that will move the file pointer to the beginning of the file, right? So think of this just like indexing into an array. And then we could do raf.seek, and then we can it actually tracks the number of bytes inside of the file, right, using .length. So we can actually pass the length in the full number of bytes into seek, and that moves us to the end of the file. And then we can move anywhere in between by passing a number between 0 and the length of the random access file. Okay, let's take a look at some of these constructors for our random access file. So the random access file class defines the following constructors. We have a random access file constructor that takes in a file object and then takes in as a second parameter a string, which is the mode of what this file provides, this random access file provides. So this constructor creates a random access file stream with the file object that we provide to it, and then the mode that we define in terms of a string. And so that the modes can be whether we can read into it, or whether we can read and write into it, or whether we want to do or whether we want to do read write on every change to the file's data. We'll talk about that in just a little bit, but you'll notice also the second constructor has effectively the same kind of parameters. Instead of a file object that you can pass into it, you can pass in also a string, like what we've done in the other sample codes. That is the file name, the pathway to the file is a string, and then also the second parameter is the mode. And so that'll also construct a random access file with the specified file name and then that mode. So in both cases, the mode determines, well, what kind of file access is permitted. And so the ones you want to think of is if the mode is just R, then that file can be read only. You can't write to it. If it's RW, then the file is open for both read and write modes. And if it is RWS, then the file is open for read, write, and every change to the file's data will be immediately written to the physical device. So every time you go to write to it, it'll happen immediately. It won't be buffered in any kind of way. Okay, so the general syntax to create a new file stream for both read-write operations is given here. We can create an instance of a random access file. We give it a label. We create a new, we invoke the constructor, and then we just pass in the parameters that you'd expect. So in this instance, we could pass in a string, which is the file name, along with the file path, and then also the mode of file access. So here, RW is a mode string that's given as a parameter to the constructor. When the file is opened by the above syntax, the file pointer is automatically positioned at the beginning of the file. So the above syntax allows the program to read from and write to the file. And so in this instance, we're calling it myfile.dat. So we're using .dat to highlight the fact that this is a binary file, that this is a data file, that if we were to open this up, it wouldn't just be text, right? .txt represents text-based, right? Something that's like UTF or probably UTF-8, so that when you open up in text editor, you can actually read it. But here with the random access file, we're actually encoding data into it. So here in this example, we'll just use the .dat. So if my file.dat already exists, the RAF is created to access it. If the myfile.dat does not exist, a new file named myfile.dat will be constructed, and then RAF is created to access that new file. So it can either access a pre-existing file or generate a new one, but that's similar to what we've seen previous, just we can read and write using that one reference. So the RandomAccessFile class in Java defines several important additional methods to support this random access. So let's look at some of these. Well, and of course, we're going to look at all the critical ones that you want to be aware of. So some of these are very common, like the close method. So obviously that method will close the random access file stream and release any system resources associated with the stream. Super important that you always close your streams whenever you're done reading or writing from them, once you no longer need them anymore, so that another application can lock into it if it needs access to it. Well, we have a Git Channel method. This method returns the unique file channel object associated with that particular file. And so that returns a file channel object. Same thing with the file descriptor. We can call Git FD, and this method returns the opaque file descriptor object associated with the underlying stream, and that will return as a file descriptor object. We have Git File Pointer, right? So this is the thing that allows us to track the position. So this method returns the current offset in bytes from the beginning of the file to where the next read or write occurs. And notice that's going to return it back as a long integer. We can also check the length of the file, and or at least the number of bytes, the length in the number of bytes of the file. And again, that's going to return back a long integer. So here we have the ability to read. That's going to return back an int. It's going to read a byte of data from the file and return a -1 if it's at the end of the stream. So recall that a byte can be encoded as an integer value. Here we can also read and pass in our byte array. Again, these are looking very similar to a lot of our other stream methods we're looking at, but consistency is one of the important things about Java. One of the nice things about Java is they're painstakingly built an API that reinforces similarity. So once you know how to do something in one class, if it's part of the same package, it's usually done in the same way across all other classes. And so that kind of repetition really makes it very predictable. So we'll have a read method where we can pass in this byte array. And of course, that reads up to the length of bytes of data from this file into the array of bytes. And then we could also do a subsection, right? Like what we've seen before. So we have a read method that's overloaded where you can pass in a byte array and then pass in an offset and a number of bytes. And so that reads up to m bytes of data from this file in an array of bytes starting from the nth byte. Here we can read Boolean. This method reads a Boolean value from this file, right? And so, of course, it's going to return a Boolean. We can read a byte from the file, right? So that's going to return back a byte. We can read a character from the file. That's going to read a character. We can read a double. That's going to return back a double data type. We can read a float. It's going to turn back a float data type. So what we can see here is because it's a binary file, we can invoke these read methods and actually pull primitive data types from the file into our Java application. We can also read fully and then pass it a byte array. And what this is going to do is it reads bead length bytes from the file into the array of bytes, into the byte array, starting at wherever the current file pointer is at. So if the file pointer isn't at 0, it's going to start wherever it's at. And so we also have read fully, where you can pass in a byte array, but also along with an offset and a number of bytes that you want to read. And that's going to operate just like read fully, but it'll take a subsection, and it still is going to start at wherever the current file pointer is at. We have the ability to read a line, so that's going to return back a string that'll go all the way, and with the delimiter being the new line character, right? Read UTF, this is going to read, this method just returns a string from the file. We have seek, where we can pass in a position as a long integer data type. So this method sets the file pointer in bytes specified as position, measured from the beginning of the file at which the next read or write should occur. And so this really is what gives us that random access into the file. We have the ability to set length using the long value. Here, what set length does is it sets a new length for this file. So we can actually change the length of the file. We have the ability to skip bytes, where we can pass in an integer, and this method will skip over n number of bytes of input, discarding the skip bytes. We have the ability to write, where we can pass in a byte array. And so this method writes the length of the bytes from the byte array to the file, starting at our current file pointer position. And then we also have overloaded that, so we can use a subset, portion of that array as well. So we can pass in the byte array with an offset and the number of bytes. So this method writes m bytes from the specified byte array, starting at nth byte to the file. Here we can also write just a byte at a time. So pass in an integer value that represents a byte and write that to our file. We can write a Boolean value to our file. We can write a byte value to our file. We can write a string. So we can pass a string and write a sequence of bytes into our file. We can write a character, which is a 2-byte value, into our file. We can write a sequence of characters represented as a string to our file, and we can write a double value. We can write a float, we can write integers, we can write longs, we write shorts. Effectively, all of our primitive data types we can write right into the random access file. So we have both write and read operations for that. Okay, perfect. So a lot of methods, but this is a super interesting class. You might find it to be pretty useful, especially with the ability to randomly access into it as if it were like an array, but it's an actual file. So it has data persistence, right? So even after your application ends, whatever you write into the random access file will continue to exist. Okay, let's take a look at some examples here. So let's take an example program based on the above methods that we looked at for the random access file class. So here we have our source code, but let's jump into IntelliJ and take a look at that there. Close these others. Okay, so here I'm going to, let's see if I can. Okay, so here I'm going to go ahead and import IO exception, because again, just like any other stream, it's always risky. I either have to throw an IO exception or I have to do a try catch box where I try to catch an IO exception. I'm also going to go ahead and import the RandomAccessFiile class so that we can use it. I'm going to create a new class and a main method. And right now I'm going to have a main method that just throws the IO exception. So I don't have to do the try catch block. So I can just focus my explanation on the code. So here I'm going to create a new random access file. And so I'm going to give it two things. I'm going to give it a path. So here it's going to actually put this, and let me make sure. Yeah, so this already exists. So no, it's my file. Yeah, my file.dat. I'm going to delete that right now. So let's delete that from my project to ensure it doesn't exist so that we're doing this fresh. Perfect. We'll do that refactor. So now we don't have that any longer. So we're going to create a new handle to a file, myfile.dat. Now, if I didn't delete it, it would have just grabbed reference to that, and that would have been fine, but I prefer to start fresh. And now my second parameter is that I want to have with that file the ability to read it and the ability to write it. Okay, so the next thing I'm going to do is, once I have a reference to this file, I'm going to say, okay, let's actually start writing some primitive data types, some Java primitive data types onto this file. So we're going to print the character S, right? And we're going to print the integer 2222. And we're going to print the double. We're going to write, I'm sorry, not print, but we're going to write the double 222.22. So illustration that all these different primitive types we can write directly into the file. Then we can move the file pointer about, like we've been writing into it. So as we've been writing into it, we've actually been changing where the file pointer is at. But now what we're going to do is we're going to change it to 0, which is going to reset it back to the beginning. Then once we do that, let's go ahead and read data from the file. So let's go ahead and read the character. And so since we're at the beginning, we know we wrote a character there as the very first entry. So we will grab that first 2 bytes, since cars encoded as 2 bytes, and we will print that out. Then we're going to tell it, okay, then read an int. Well, an int's encoded as 4 bytes, right? So we'll go ahead and that out and read that. And then we'll go ahead and read a double, and a double is double the size of a float. A float is typically 4 bytes. So a double precision of that is 8 bytes. So we will then read double, pull that double value out, and advance our file pointer by 8 bytes. And then we will then change our position to position 2. And then we'll be able to read int again, position 2, because the thing we read, which is wrote into there, is a character that consumes 2 bytes. So if I put my seq at position 2, then that's 2 bytes into my sequence. So that means that's going to put me at where my integer number starts. So one of the tricky things that you should be aware of if you ever use RandomAccessFile class is that you're counting based off of the bytes. So you have to be very aware that you're not advancing based off of like the index position of what the data type is, like you are with an array, right? Because you can have, it's just a sequence of bytes. So it could be combined data. Like, for instance, we're writing characters, integers, and doubles in here. So you have to track where your next set of encoded bytes for a primitive data type starts or ends. So since we know we wrote a character, then we know that the beginning of our int would be two bytes into our random access file. So we're going to go and do read int, and that should print out again. And in fact, let me run this. So as I'm talking about this, we can actually see the output. So again, when we were reading the car here, that's that S. And when we were printing the int here, that's that 222. And when I was reading the double here, that's this 222.22. And then when I move the position by 2, when I reset it to be 2 bytes into the random access file, I can then read int again and access that int. And then I can go ahead and move all the way to the end, right? Doing file.length, that's going to go to the end and append and now what we're going to do is we're going to write a Boolean value at the very end. And so now what we're going to do is we're going to move the file pointer to the 4th position, and we're going to read that Boolean value. And here you can see we will then have the value true. And then we will close our stream. Excellent. And then just an explanation of the slides, but we've already walked through that. I want to show another example of this just so you can get a better idea of this. So let's create another sample program where we can append an item to an existing file using the RandomAccessFile class. So here, what we're going to do is, again, let's jump back over here. Where is this? Okay, so I'm going to delete this. Okay. Let's refactor. Okay, so it doesn't exist. Let me open up my RandomAccessFile tester 2. So what we're going to do here is we're just going to import our IO exception. We're going to import our RandomAccessFile class. We're going to create a new class. We're going to create a main method that throws an IO exception because we always need to do that for these streams. Now, the idea is that I want to open a pre-existing file, but so I'm going to run this application twice effectively. So we're going to make it, and then we're going to overwrite, or we're going to write to it. So here we have the RandomAccessFile, where we're going to instantiate a new RandomAccessFile. And just to illustrate that, it doesn't have to be a .dat. Like we can add essentially text into these files if we wanted to, right? Because we can encode that. So here, I'll go ahead and create a file, cityfile.txt, and I will have the mode where we can read and write. What we'll do is we're going to append. So to append, we're going to move to the end of the file. If this is an empty file, the end is the beginning. Then we're going to write the bytes using the string New Orleans, and then we're going to put a new line character after that. So we're going to effectively append New Orleans. When we initially run this, it's just all through New Orleans. When I run it the second time, it should then append New Orleans into the file. Then we'll close our file, and we'll also put a report that we had successfully written. So let me go ahead and run this. So I deleted that file before. So now it should now exist. So we see we've successfully written. Here's a file. Let me open it up. New Orleans, perfect. So now what I'm going to do is I'm going to run it again so that it's a pre-existing file. So we're going to run that. We ran it. We got successful again. I'm kind of going over here, and yep, you can see I've now appended the second writing of New Orleans after the first. I was able to do that by setting the file pointer to the end, right, before I decide to write any bytes. That way I preserve the bytes that were in the random access file ahead of time. Excellent. And I just want to show one more sample of this random access file, just to illustrate that this is an interesting way that we can go ahead and alter data and access data into here. Effectively soon, though, very soon, we're going to learn a much more powerful way of saving our Java data into files using serialization. And that'll allow us to do more than just primitive data types. That'll allow us to do things like arrays and objects and things like that. But this is kind of motivating where we're going to be going. Okay, so let's, for the last example, I want to use the file pointer for random access. So let's take one last example based on the above examples, just for some more practice. Let's jump into the source code. It's here on the slide, but I prefer to come here and read it in our IDE. So here we're going to import IO exception. Here we're going to import the random access file so we can go ahead and instantiate and use it. We're going to create just a tester file so that we can have a main method. I'm going to have my main method throw the IO exception so I don't have to do try catch blocks. Obviously not the preferable thing, but it's easier to kind of step to the code without having all the nesting that try catches do. Okay, so here I'm going to create a random access file object. And it's going to be iofile.dat. And here, what I'm going to do is I'm actually going to delete the pre-existing one I have here. So let me go ahead and delete this so it doesn't exist. Yeah, let's delete that. You have to do that refactor. So now we don't have that anymore. Okay, so the first thing I'm going to do is I'm going to clear the file to destroy whatever old data was already there. Well, now we don't have to worry about that because I just did that manually, but I could rerun this again and you'll see that that would work. But if we wanted to overwrite everything, if we wanted to empty a file, we can just set its length to 0, right? That it's 0 bytes, and that'll erase everything. Then we want to write a new set of integer values to the file. So what we can do here is I can just create a for loop with a loop control variable starting at 0 and step through increment until it hits 10. And then I'll just write that int, the loop control variable's value with the right int method to the file, to my random access file. And then I'm going to go ahead and print it. And actually, let's see what happens. Let me run this. So as we do these print statements, we can see. So here, if I want to check the current length of my file, it's going to say it has 44 bytes. And of course, that makes sense, right? Because we said each integer encoding is 4 bytes. And I'm starting at 0. I'm going all the way until 10. I'm including 10. So that's 11 different integer values that we've written to the file. So since each integer is 4 bytes and there's 11 of them, it's going to be 44 bytes long. Perfect. So that makes sense. So now what we're going to do is we're going to set our file pointer to the position of 0. So now if we go and read the first integer from where our file pointer is at, we're going to get the value of 0. And that makes sense. That's the first thing that we authored into it in the for loop. And then we're going to get the second number. So let's go ahead and read int again. And each time we read from it, our file pointer is going to advance. So now I'm going to get that second number, which is going to be 1. Okay, now look at this. What we can do is we can now use seek and actually multiply by the number of bytes. So here we can actually advance to where if we have a contiguous block of data where we know the bytes and it's uniform, and that's true with the integers, I can multiply, right? I'm like, okay, if I want to get to the 9th, if I want to get to like the 9th value and access that, I can take the number of bytes that an integer is, so that's 4, and multiply in the number of steps I want to take, like the number of elements I want to traverse. And if I multiply that and pass that value to my seek, I can grab the 9th number, right? So the 9th number would be 9 times 4, perfect. And then if I want to modify the 10th number, I can go ahead and since I've advanced here, since I've done a read here, I've changed the file pointer on line 28, then I've read. So technically my file pointer is now at number 10. So if I do a write int here, I'm going to overwrite the 10th number. So now after I overwrite and then change the file pointer using seek, and I'm going to do that same trick. I'm going to take the number of bytes, which is 4, and I'm going to multiply it by the element number I want to grab, which is the one I just overwrote, which is going to be the 10th element. We can see when I go and read that element now, that is now going to be 222. So you can see how I can randomly access any location into my file and overwrite or read from it. Here, I'm going to now append a new number at the very end of the file. So I'm going to do seek, and I'm going to pass in the file.length. That's going to put me at the very end of the file. And then going to write a new integer, 333, at the very end of it. And now if I go ahead and if I query the length of my file, I'm going to see it's increased by 4 bytes, right? Because now I've added a 12th element. So it's now 48 bytes large. And so now if I do seek for the 11th element times 4 and read that, you'll see I'm going to get that new element that I had just added in, the 333. And that really shows you, I think this example really shows you how powerful we can randomly read and write across our file, and how we can do some simple computations to grab data from anywhere inside of it. So there is a little bit of bookkeeping involved to use this in a very powerful way. So is there any questions regarding this? So this is really the kind of final example that I wanted to show you with byte streams, because we've essentially just focused on byte streams up to this point. And I feel like that was the epitome of what we were leading to in terms of byte streams, is the random access file class.